Across the ancient world, archaeologists keep finding objects where they should not exist. Baltic amber in Syria, British tin in Mediterranean shipwrecks, and Pacific obsidian thousands of kilometers from its volcanic source. Together, they reveal a world connected by traders, sailors, migrants, and ideas. We begin with number 10, the Alpine jade axes. Number 10. The Alpine jade axes. High in the southwestern Alps, prehistoric quarry workers climbed into a landscape of steep slopes, exposed rock, and unpredictable weather. They were searching for exceptionally hard green stone, including jadeite and eclogite. Reaching the deposits demanded effort. Extracting the stone demanded even more. Then came the slow work of shaping and polishing it. Some finished axes were practical tools. Their edges could cut wood, clear land, and support daily life in farming communities. But others were different. They were unusually large, remarkably thin, or polished so carefully that heavy use might have damaged them. These objects were made to be seen, and they did not remain near the mountains where their stone had formed. Alpine jade axes have been discovered across Western and Central Europe, sometimes more than 1,000 kilometers from their geological source. Some reached regions near the Atlantic. Others moved northward or eastward. That distance can now be measured because stone carries evidence of its origin. Researchers examine its mineral structure and compare it with samples from known deposits. The internal composition acts like a geological signature. An axe found far from the Alps can still preserve the identity of the mountain from which it came. What the stone cannot reveal is the route. No written record names the people who carried these axes. No surviving map shows where they stopped. One traveler may not have completed the whole journey. An axe could have moved from one community to another through marriage, seasonal gatherings, ceremonial gifts, alliances, or repeated exchanges between neighboring groups. The object may have traveled slowly, perhaps changing owners many times. Its meaning may have changed along the way as well. Near the quarry, it might have represented skilled labor or access to a rare material. Farther away, its distant origin may have made it more powerful. Some axes were placed in graves. Others were deposited in rivers, wetlands, or locations that appear ceremonial. They may have expressed status, identity, belief, or relationships between communities. Their value was not necessarily based on usefulness alone. Distance itself could create value. Yet the evidence remains incomplete. Some axes entered museum collections long ago, before archaeological recording became systematic. Their original find locations or contexts may be uncertain. Even when scientists identify the stone source, they cannot always reconstruct the social world around the object. Still, one conclusion is difficult to escape. Long before cities, empires, coins, or written contracts, prehistoric communities were connected across enormous areas. Those networks did not need a central government. They could survive through trust, obligation, memory, and repeated human contact. And the axes may not have traveled alone. People who exchanged rare objects could also exchange stories, techniques, symbols, and marriage partners. A polished green axe was more than a tool. It was evidence of relationships stretching far beyond one village. But the next object traveled even farther. It began as fossilized resin near the cold shores of northern Europe. Thousands of kilometers away, it appeared in a burial in Syria. Number 9. Baltic amber in Syria. Amber begins as tree resin. Over immense periods of time, pressure and chemical change can transform that resin into a material hard enough to survive for millions of years. Along the Baltic coast, storms still wash pieces onto beaches. To ancient collectors, amber must have seemed unlike ordinary stone. It was lightweight. It could be polished until it glowed. It felt warm in the hand. Sometimes it held insects or plant fragments trapped inside. Across the ancient world, amber became a material for beads, pendants, and ornaments. But appearance alone cannot prove where a piece came from. Fossil resins exist in several regions, including places much closer to the eastern Mediterranean. That is why beads recovered from an Iron Age burial at Hama in western Syria required scientific testing. Researchers used chemical analysis, including infrared spectroscopy. Different resins absorb infrared energy in distinctive patterns. Those patterns can be compared with samples from known geological sources. The Hama beads matched Baltic amber. Their material had originated more than 3,000 kilometers to the north. That does not mean one merchant carried them directly from a Baltic beach to Syria. The more likely story is a chain of exchanges. Amber may have moved from coastal collectors into inland Europe. From there, it could pass through Central European, Mediterranean, Balkan, Anatolian, or Near Eastern networks. At each stage, someone made a decision. Keep it, trade it, reshape it, give it as a gift, carry it farther. The person eventually buried with the beads may never have known where the amber first entered human hands. The original source could have been forgotten after generations of exchange. Or perhaps the mystery of its origin increased its value. Rare materials often gain prestige because they come from beyond the familiar world. Their distance becomes part of their meaning. The Hama beads reveal something important about ancient trade. A network does not require every participant to understand its full scale. A trader in one region may know only the next market. A craftsperson may know who supplied the raw material, but not where it formed. The final owner may know nothing about the journey at all. Yet local exchanges can connect to other local exchanges until an object crosses a continent. Archaeology sees the entire distance only because modern science can identify both ends. The amber proves movement. It does not identify every carrier. It reveals overlapping networks without showing us exactly how they were organized. That uncertainty is not a weakness in the story. It is part of the story. Ancient connectivity often emerged from thousands of small transactions rather than one planned route. The bead reached Syria because many communities, each acting within its own world, formed part of something much larger. But these exchanges still followed land, rivers, and coastlines. The next discovery crossed an environment with far fewer places to stop. In the Pacific, archaeologists found a small flake of volcanic glass thousands of kilometers from the island where it had formed. To explain it, they had to stop seeing the ocean only as a barrier. Number 8. Lapita obsidian across the Pacific. Obsidian forms when volcanic lava cools so quickly that crystals do not have time to develop. The result is a natural glass. When broken carefully, it produces an edge sharper than most ordinary stone. That made it useful for cutting. It also gave archaeologists an unusual advantage. Obsidian from different volcanoes often contains distinctive combinations of trace elements. Even a tiny fragment can be compared with samples from known sources. This is how obsidian found in early Lapita archaeological contexts became evidence of extraordinary movement. Fragments recovered in New Caledonia were chemically linked to sources in the region of New Britain, far to the northwest. The straight-line distance was already immense. The actual route may have covered more than 2,000 kilometers, possibly much farther. The people associated with Lapita sites were part of one of the great maritime expansions in human history. More than 3,000 years ago, communities moved eastward through the Pacific, reaching islands that had never before been settled by humans. They carried plants, animals, pottery traditions, tools, and social customs. Their voyages demanded knowledge that left little physical evidence. Sailors had to understand winds and currents. They watched stars, clouds, birds, and the patterns of waves around unseen land. They had to carry food and water while navigating through open ocean. The obsidian shows that settlement did not necessarily end contact with earlier homelands. People living on newly settled islands may have remained connected to relatives, partners, or allied communities far behind them. The stone may have been valued because it was useful. It may also have carried memory. A fragment from an ancestral island could represent identity, belonging, or obligation. Once again, the source can be identified more confidently than the root. The obsidian does not prove that one canoe traveled directly from New Britain to New Caledonia. The material may have moved in stages. One group carried it to a neighboring island. Another carried it farther. Over time, the stone crossed a vast maritime network. Relay exchange does not reduce the achievement. It makes the network more impressive. Each stage depended on active relationships. The material could continue moving only if communities remained connected. The Pacific was not empty space separating isolated islands. For people who knew how to navigate it, the sea was filled with roots. Those roots were remembered rather than drawn. The canoe, sail, rope, and food supplies have mostly disappeared. The tiny obsidian flake survived. Its chemistry still preserves the beginning of the journey, even when every stop in between has been lost. Stone can endure for thousands of years. Other things are far more difficult to transport and preserve. In the deserts of North America, archaeologists found traces of a tropical crop and the remains of brightly colored birds. Both came from environments far to the south. Number 7. Mesoamerican goods at Chaco Canyon. Pueblo Bonito stands in Chaco Canyon as one of the most complex structures in the ancient American Southwest. Its many rooms, formal spaces, and concentration of unusual objects have long raised questions. Was it a political center? A ceremonial gathering place? A residence for powerful families? Or did it serve several roles at different times? One clue came from pottery. Some vessels appeared empty. But an empty jar can still preserve the chemistry of what it once held. Researchers tested residues inside ceramic fragments and detected compounds associated with cacao, including theobromine. Cacao could not grow in Chaco Canyon's dry environment. It had to come from much farther south. The discovery suggested that a tropical product had traveled across dramatically different landscapes before reaching the canyon. Then another form of evidence deepened the mystery. Archaeologists had also found the remains of scarlet macaws. These large red, blue, and yellow birds belong to tropical and subtropical environments. They are not native to the high desert of New Mexico. Moving a bead or stone over long distances is difficult. Moving a living bird is something else entirely. A macaw must be fed. It must be protected from cold and injury. Its handlers must understand enough about the animal to keep it alive through every stage of the journey. Radiocarbon dating showed that macaws were reaching Chaco earlier than some researchers had expected. Their presence points to more than accidental exchange. The birds may have been valued for their feathers, their color, their rarity, or their place in ritual life. Cacao may also have carried ceremonial and social significance. Together, they reveal a network capable of moving perishable food, living animals, and cultural practices. The routes remain uncertain. People from Chaco may have traveled south. Southern traders may have traveled north. More likely, at least some goods passed through several intermediate communities. Northern Mexico and the American Southwest contained their own networks, any one of which could connect with another. What matters is that Chaco was able to acquire products from far beyond its local environment. Those products may have strengthened authority. Rare foods, brilliant feathers, marine shells, and other distant goods could be used in ceremonies or displays of status. Someone who controlled access to them controlled more than material wealth. They controlled contact with a wider world. Foreign goods brought distant landscapes into the canyon. A tropical bird made the south visible. Cacao made it consumable. Connectivity was beginning to shape ritual, identity, and political life. But Chaco was mainly a destination in this story. The goods arrived after being produced elsewhere. At the next site, archaeologists found evidence of a city positioned in the middle of a long-distance system. Raw material entered. Specialists transformed it. Finished objects moved onward. Number 6. The lapis lazuli workshops of Shari Sokta. Few ancient materials are as visually striking as lapis lazuli. Its deep blue surface can be crossed by pale veins and flecks of golden pyrite. For ancient craftspeople, it offered a color rarely found in durable natural stone. Lapis appears in jewelry, seals, inlays, and elite objects from Mesopotamia to Egypt. Yet the major geological sources lay far to the east, especially in the mountain regions of Afghanistan. How did stone from remote mines reach cities thousands of kilometers away? Part of the answer emerged at Shari Sokta, in what is now southeastern Iran. Archaeologists did not simply uncover finished ornaments. They found broken fragments, partially shaped pieces, unfinished beads, drilling debris, waste from cutting and polishing. These were the remains of production. That distinction matters. A finished bead can travel far from the place where it was made. Workshop waste usually stays behind. It records the stages that disappear once an object is completed. Researchers analyzed the composition of the blue stone and compared it with samples from known sources. Most of the tested material was consistent with lapis from Badakhshan in Afghanistan. At least some evidence suggested that other Central Asian sources may also have contributed. Shari Sokta stood between the mountain deposits and consumers farther west. Raw stone could arrive from mining regions. Craft specialists then shaped, drilled, and polished it. The finished objects could continue toward Iran, Mesopotamia, Arabia, and other markets. The city may have been a workshop center, a redistribution point, or both. Its position gave it importance without requiring control over either the mines or the final consumers. This was no longer the movement of one rare object. It was a system. Someone had to extract the stone. Someone had to transport it. Specialists needed tools, workspace, and training. Merchants or intermediaries had to understand where demand existed. Finished pieces then had to enter another chain of movement. The labor was divided across distance. One region supplied the raw material. Another transformed it. Others consumed it. The people involved may never have met, yet their work became part of the same object. The evidence still has limits. Geological sourcing depends on reference collections. An ancient deposit that has not been sampled may be absent from the comparison. Badakhshan was clearly important, but it may not have been the only source. The political organization behind the movement is also uncertain. Palaces, merchants, households, mobile groups, and independent craftspeople may all have participated. What remains clear is that Shar-I Sokta was not simply receiving luxury goods. It occupied an active position inside a production network. Imported material supported a specialized urban economy. And that raises a deeper question. Stone can be carried without the people who know how to work it. A technique cannot. In Mesopotamia, microscopic marks on carnelian beads suggested that knowledge associated with the Indus civilization had crossed cultural boundaries. Perhaps the craftspeople crossed them too. Number 5. Indus bead makers in Mesopotamia. Carnelian is a reddish variety of chalcedony. Through careful heating and polishing, craftspeople can deepen its color and produce a smooth, luminous surface. In the Indus civilization, bead makers developed highly specialized methods. They created long, narrow forms. They drilled remarkably precise holes. They produced distinctive decorations that required patience, skill, and controlled tools. When similar beads appeared in Mesopotamian cities, archaeologists faced several possibilities. They may have been manufactured in the Indus region and exported as finished objects. Raw carnelian may have traveled west, where local craftspeople worked it. Or specialists trained in Indus traditions may have moved abroad and established production there. The surface of a bead cannot answer that question by itself. Researchers had to look closer. They studied the chemical composition of the stone. They compared shapes and decoration. They examined drill holes and microscopic manufacturing traces. Some carnelian was consistent with Indian sources. Certain working methods closely resembled those known from Indus workshops. But the evidence was not identical across every bead. That variation suggested a mixed picture. Some objects may have arrived finished. Others may have been made in Mesopotamia using knowledge that had traveled from the East. The broader archaeological context makes sustained contact plausible. Indus-style seals have been found in Mesopotamia. Shell objects, weights, beads, and other materials point toward exchange through the Persian Gulf and Arabian Sea. Mesopotamian texts also refer to a distant place often identified with the Indus world. But proving the movement of a technique is more difficult than proving the movement of a stone. Skills can be copied. A local craftsperson can study an imported object. Similar solutions can sometimes develop independently. This is why the sequence of production matters. The angle of a drill hole, the marks left by a tool, the order in which a bead was shaped, heated, decorated, and polished. These details preserve behavior. They do not reveal the ethnicity of the craftsperson. They can, however, identify a technical tradition. If Indus-trained specialists worked in Mesopotamia, they may have traveled temporarily or settled for longer periods. They could have served merchants, palaces, temples, or private customers. They may have taught local apprentices. Even after the original specialists left, their knowledge could remain. An imported object changes possession. Transferred skill changes production. It affects what people can make, what buyers expect, and what local workshops become capable of doing. There may never have been one single explanation for every bead. Some traveled as finished goods. Some may have been produced from imported stone. Some techniques moved through observation or teaching. Some craftspeople may have moved as well. Ancient networks could operate through several mechanisms at once. The next discovery reveals a system larger than any individual workshop. It involved a metal essential to the Bronze Age. And some of that metal may have crossed Europe from the Atlantic coast to the eastern Mediterranean. Number 4. British tin in Mediterranean shipwrecks. Bronze is created by combining copper with tin. The result can be harder and more durable than copper alone. It was used for tools, weapons, armor, fittings, and objects that expressed wealth or authority. Copper existed in several parts of the ancient Mediterranean and Near East. Tin was much harder to obtain. That imbalance created one of the Bronze Age's most important logistical problems. Where did ancient societies find enough tin to support large-scale bronze production? For generations, the answer remained uncertain. Possible sources existed in several regions. Once metal was melted, mixed, recycled, and reshaped, its origin became difficult to trace. Shipwrecks offered a rare opportunity. Tin ingots recovered from the sea had not yet disappeared into finished bronze objects. Researchers combined several analytical methods. They examined trace elements. They compared lead isotopes. They studied tin isotopes. No single test provided a complete answer. Together, the results linked some ingots to ore deposits in southwestern Britain, especially Cornwall and Devon. The implication was extraordinary. Tin from the Atlantic edge of Europe had reached the Mediterranean. Some of it may have traveled roughly 4,000 kilometers before sinking. There was probably no single road connecting Britain with the eastern Mediterranean. The metal could have moved by coastal boat, river, overland path, and repeated exchange. It may have changed hands many times. Miners in Britain did not need to know which distant kingdom would eventually use it. Bronze workers in the Mediterranean may not have known where the tin had been extracted. Each group only needed contact with the next stage. The result was a supply chain without one obvious center. Communities that left no palaces or written archives could provide material essential to states with armies, cities, and monumental buildings. Their contribution is easy to miss because the final bronze object receives more attention than the distant source of one ingredient. Yet without tin, the technological system changes. The metal connected miners, traders, boat crews, regional brokers, port workers, and craft specialists. Political power in one region depended partly on people living far beyond its control. That dependence created both strength and vulnerability. A kingdom could command workshops and soldiers. It could not create tin where geology had placed none. The network had to remain open. Scientific caution is still necessary. Ore deposits can share similar signatures. Reference samples are incomplete. Ancient recycling can complicate the chemistry. The source may be easier to identify than the exact route. But even with those limits, the discovery transforms the map of the Bronze Age. Atlantic communities were not peripheral, simply because they lacked the institutions of Eastern kingdoms. They were part of the system that allowed those kingdoms to function. So far, the evidence has followed objects, animals, food, materials, and skills. All of them can move without fundamentally changing who lives in a region. The next discovery revealed something far more dramatic. Ancient DNA showed that one of prehistoric Europe's largest cultural transformations involved the movement of people themselves. Number 3. Ancient DNA and the steppe migrations. For much of archaeological history, migration was difficult to prove. Researchers could see changes in pottery, tools, burials, and settlement patterns. But objects do not always move with populations. A new style can be copied. A technology can spread through teaching. A burial custom can change because beliefs have changed. The same archaeological pattern might be explained by trade, local development, elite influence, or migration. Ancient DNA introduced a different kind of evidence. Genetic material can sometimes survive inside bones and teeth for thousands of years. The dense portion of the temporal bone, near the inner ear, often preserves especially useful DNA. Researchers extract small samples in controlled laboratories, where contamination must be carefully managed. The recovered sequences can then be compared across individuals and populations. When scientists analyzed ancient genomes from Europe, they found evidence of a major shift. People associated with the corded ware, archaeological complex in Central and Northern Europe, carried a large amount of ancestry related to populations from the Pontic-Caspian steppe. In some studied groups, roughly 3/4 of their ancestry was connected to steppe populations resembling those associated with Yamnaya pastoralists. This was not the trace of a few merchants. It pointed to substantial migration and population mixture. People moved westward. They formed families. They joined, replaced, or mixed with existing communities in different proportions. Their ancestry became part of later generations. The findings transformed a debate that had lasted for decades. Cultural change in prehistoric Europe could no longer be explained only as the spread of ideas. Migration had played a major role. But genetics cannot tell the whole story. DNA does not reveal which language a person spoke. It does not identify personal beliefs or social identity. It cannot tell us whether movement was peaceful, violent, gradual, seasonal, or politically organized. A genetic population is not automatically the same thing as an archaeological culture. Those questions still require graves, settlements, artifacts, environmental evidence, and careful regional study. The migrations also unfolded differently from place to place. Some areas experienced major demographic change. Others show more mixture and continuity. There was no single moment when one population simply replaced another across the whole continent. The process involved generations of movement, contact, conflict, cooperation, and family formation. Even with those qualifications, the scale is unmistakable. Ancient connectivity did not stop at exchange. It could reshape the ancestry of entire regions. Migrants carried more than genes. They carried animals, technologies, customs, memories, and social relationships. When populations moved, the connection did not end when a journey was complete. It continued through descendants. Ancient DNA also changes the way archaeologists look at artifacts. When a new pottery style appears, researchers can ask two separate questions. Did the design move? Or did the people who made it move? Sometimes the answer is both. Genetics does not replace archaeology. It forces archaeology to connect biological movement with material evidence. Yet even ancient DNA usually reveals patterns spread across generations. The next discovery captures something more immediate. Around the 14th century BCE, a ship sank near the southern coast of Anatolia. Its cargo remained on the seabed. When archaeologists excavated it, they found an international network preserved in the middle of a voyage. Number 2. The Uluburun shipwreck. The first objects noticed near Uluburun were copper ingots. They had a distinctive shape, stretched at the corners, like animal hides. More appeared beneath them. Then pottery, glass, tools, weapons, ivory, resin, jewelry, weights, food remains, and personal belongings. The wreck eventually produced one of the richest Bronze Age cargoes ever excavated underwater. It sank around 1320 BCE, during a period when powerful states across the Eastern Mediterranean and Near East were linked through diplomacy, conflict, marriage alliances, tribute, gift exchange, and trade. Egypt, the Hittite world, Mycenaean centers, Cyprus, the Levant, and Mesopotamian states did not exist in isolation. Uluburun preserved the material reality of their connections. The ship carried large quantities of copper. It also carried tin in a proportion broadly suitable for bronze production. That cargo alone represented strategic value. Metal supported tools, weapons, armor, buildings, and political power. But the vessel carried far more than metal. There were glass ingots in vivid colors, containers of resin, ivory from animals living far from the wreck site, amber associated with northern regions, carnelian and agate, pottery linked with different parts of the Mediterranean and Near East. Luxury goods, raw materials, foodstuffs, and personal objects were packed into the same ship. Each category points toward a different source. Together, they reveal networks extending across the Mediterranean, Africa, the Near East, and regions beyond. Shipwrecks preserve something rarely available on land. Imported objects found in a palace may have accumulated over centuries. A grave may contain an heirloom made long before the burial. A settlement can mix materials from different periods. A wreck captures a much narrower moment. The Uluburun cargo was together because it was moving together. That makes the site unusually direct evidence of ancient transportation. Still, the purpose of the voyage remains debated. Was the vessel carrying royal goods? Some objects seem appropriate for diplomatic exchange. Was it a commercial shipment with cargo intended for several buyers? The weights and diversity of goods could support that interpretation. Perhaps it was both. State-controlled materials, diplomatic gifts, merchant goods, and private belongings may all have traveled on the same ship. Modern divisions between government activity and private commerce may not fit the Bronze Age. Palaces, merchants, sailors, officials, and craftspeople could participate in overlapping systems. The ship's identity remains uncertain. Its construction, anchors, cargo, and personal objects offer clues. No surviving document gives its name, owner, crew list, or full itinerary. It may have visited several ports, loading and unloading goods along the way. Some items had probably traveled through multiple regions before reaching the vessel. Uluburun was not the beginning of the network. It was one moving part inside it. Copper had to come from mining districts. Tin came from somewhere else. Resin came from forests. Ivory passed through hunters, collectors, and traders. Glass required specialist production. Food had to be harvested, stored, and transported. Every object reached a port before it could be placed on board. The ship gathered several land-based systems into one maritime voyage. Underwater excavation allowed archaeologists to preserve those relationships. Divers recorded objects within a grid before removing them. The position of the cargo mattered. It could reveal how the vessel had been loaded and how its contents shifted as it sank. Personal possessions offered hints about the people on board. Wood fragments helped researchers study shipbuilding. Even the wrecking process became part of the evidence. Uluburun shows that late Bronze Age connection involved more than occasional exotic gifts. It required transportation systems capable of moving tons of material. Those systems crossed political boundaries. They connected palaces with mines, farms, forests, workshops, ports, and ships. Yet Uluburun remains one vessel, one interrupted journey, one extraordinary moment. The final discovery reveals something broader. At Berenike, on Egypt's Red Sea coast, archaeologists uncovered centuries of long-distance exchange. Not only cargo, but warehouses. Not only foreign objects, but foreign languages and religious traditions. Not simply a route, but a community built around connection. Number 1. The Indian Ocean world at Berenike. Berenike stood in a difficult landscape. The Red Sea coast of Egypt is dry, remote, and separated from the Nile Valley by desert. Fresh water was limited. Food and supplies had to be organized. Maintaining a permanent port there demanded planning. But the location offered access to one of the ancient world's most important maritime systems. Ships sailing south could reach ports along Africa and Arabia. Sailors who understood the seasonal monsoon winds could cross the Indian Ocean toward the Indian subcontinent. From Berenike, goods moved by desert roads toward the Nile and then onward to Alexandria and the Mediterranean. The port connected several worlds. Archaeologists uncovered that history layer by layer. Warehouses, ropes, ship timbers, pottery from distant regions, plant remains, inscriptions, religious objects. Among the most striking discoveries were thousands of black peppercorns. Pepper does not grow in Egypt. It came from South Asia. One storage vessel contained several kilograms. This was not a single seed carried as a curiosity. It was a commercial quantity. Before it reached Berenike, the pepper had to be cultivated, collected, packed, transported to a port, loaded onto a ship, carried across the sea, unloaded, stored, and distributed. Different people handled each stage. Archaeobotany makes such journeys visible. Seeds, wood, pollen, and plant fragments can survive through drying, charring, or protected burial. Once identified, they reveal treasure materials that rarely appear in monuments. Pepper brings long-distance exchange into everyday experience. It affected taste. It could be used in food, medicine, and displays of status. A plant grown in South Asia became part of life in the Roman world. Berenike also contained evidence that people and beliefs traveled with goods. Objects associated with South Asian religious traditions were found at the port. Inscriptions appeared in more than one language. These discoveries raise questions that a jar of pepper cannot answer. Who was present? Merchants staying for one season, sailors waiting for favorable winds, permanent foreign residents, local people adopting practices brought by visitors, travelers carrying personal objects of worship. Several explanations may be true at once. Ports are rarely simple communities. People arrive for different reasons. Some remain for months. Some build new lives. Others leave almost no trace beyond a broken vessel, a short inscription, or a misplaced object. The archaeology also reveals the infrastructure that made connection possible. Ships alone were not enough. Cargo needed warehouses. Travelers and animals needed water. Desert roads required guides, stations, and supplies. Goods had to be transferred from ships to caravans. Officials may have recorded, taxed, or inspected shipments. Craftspeople repaired equipment. Laborers unloaded cargo. Interpreters helped people communicate. Religious spaces gave travelers identity and reassurance far from home. Berenike was not simply a point on a route. It was a system built from human labor. Its success depended on knowledge of seasons and winds. Indian Ocean travel followed the rhythm of the monsoon. Sailors could depart with winds blowing in one direction and return when the seasonal pattern changed. That knowledge made regular long-distance voyages possible. It did not make them safe. Ships still faced storms, reefs, disease, shortages, piracy, and navigational error. But the routes became reliable enough to sustain exchange across generations. The evidence at Berenike covers centuries. That creates a danger for anyone telling its story. Objects from different periods cannot be placed into one imaginary moment. The port changed. Political control shifted. Trade routes expanded, weakened, or redirected. Demand changed. Communities changed. Religious life changed. Every discovery must remain connected to its own date and context. Even so, the combined evidence reveals something no single artifact could show. At Berenike, connectivity became an environment. A person standing near the harbor might hear several languages. Cargo arrived from Africa, Arabia, and India. Imported spices entered local storage. Religious traditions traveled with sailors and merchants. Caravans left across the desert, carrying goods toward the Nile. The distant world was present in ordinary work. That is why Berenike ranks first. The Alpine axes show rare objects moving across prehistoric Europe. Baltic amber reveals exchange stretching from northern Europe to Syria. Pacific obsidian proves that open ocean could become a route. Chaco shows food, animals, and ritual materials crossing ecological boundaries. Shari Sokta exposes a city processing stone from distant mines. Indus beads suggest the movement of technical knowledge and perhaps craftspeople. British tin reveals a supply chain supporting an entire technological system. Ancient DNA shows populations moving across a continent. Uluburun captures international cargo while it was physically in transit. Berenike brings these forms of connection together: raw materials, finished goods, food, ships, languages, beliefs, infrastructure, merchants, sailors, workers, visitors, and perhaps permanent communities formed far from ancestral homes. The ancient world was not equally connected everywhere. Most people may have spent their lives close to where they were born. Travel remained slow, expensive, and dangerous. Wars could close routes. Environmental change could destroy ports or make roads unusable. A network might flourish for generations and then disappear. But isolation was never the complete story. Across the Indian Ocean, people created systems in which distant societies became linked through demand, knowledge, and movement. At Berenike, archaeology allows us to see that system not as one line between two places, but as a lived human world. So what does it really mean to say that the ancient world was connected? It does not mean that everyone understood the size of the planet. It does not mean that goods moved freely through every region. And it does not mean ancient exchange was identical to modern globalization. The reality was more fragmented. Connections overlapped. A jade axe could move through ceremonial exchange. Amber could pass through a chain of communities. Obsidian could travel between islands through kinship and maritime obligation. Cacao and macaws could strengthen ritual authority. A workshop city could transform imported stone for distant consumers. Craft specialists could carry techniques across cultural boundaries. Tin could move through a supply system so extensive that the miners and bronze workers may have known nothing about one another. Migration could reshape entire populations. A ship could carry materials from several regions at once. A port could turn long-distance exchange into daily life. Archaeologists reconstruct these networks because different forms of evidence answer different questions. Geology identifies where stone formed. Spectroscopy distinguishes one resin from another. Residue chemistry reveals vanished food and drink. Isotopes connect metal with ore deposits, and sometimes people with landscapes. Microscopic marks preserve technical behavior. Ancient DNA reveals ancestry and migration. Archaeobotany recovers crops and spices. Underwater archaeology preserves cargo in transit. Inscriptions reveal names, languages, dedications, and identities. No single method provides the whole map. Together, they recover it from fragments. That map must remain cautious. A foreign object proves movement, but not always direct contact. A shared design may reflect imitation rather than migration. Genetic ancestry does not automatically reveal language. An imported religious object does not prove that a large foreign community lived nearby. The strongest historical interpretation separates what the evidence demonstrates from what it only suggests. Even with those limits, the larger pattern is clear. Ancient societies were shaped by materials, people, and knowledge arriving from beyond their local horizons. An object found in one place may have begun its history thousands of kilometers away. A stone tool can preserve evidence of a mountain its owner never saw. A person can carry ancestry shaped by journeys made generations earlier. A city can depend on miners, sailors, farmers, and craftspeople who live outside its political world. Civilizations were not sealed containers. They were meeting points. Some connections were displayed in palaces, ports, and luxury goods. Others remained hidden inside drill marks, plant residues, isotopic signatures, and ancient bones. Many more have vanished. Wooden ships decayed. Textiles disappeared. Food was consumed. Stories went unwritten. Travelers died without leaving identifiable graves. Most ordinary exchanges left no durable object for archaeologists to recover. The networks we can reconstruct may represent only a fraction of those that once existed. A bead of amber, a flake of obsidian, a peppercorn, a tin ingot, a fragment of human bone. Each seems small when viewed alone. Its importance begins when the source is discovered. Someone extracted the material. Someone shaped it. Someone carried it. Someone exchanged it. Someone gave it meaning. And centuries or millennia later, someone recognized that it had traveled much farther than anyone expected. The ancient ruins were never truly isolated. Their connections were simply waiting to be traced. And beneath unexplored settlements, forgotten harbors, buried coastlines, and the floors of ancient seas, the next route may already be there. Not drawn on any surviving map, but preserved inside an object that has not yet been understood.